Welcome back to Infinite Lives, and today we're going to pick up on a favourite game of mine back in the 80s, the Fingers Malone. I'm not sure if you're familiar with it, but let's just take a look. This was, in my opinion, a popular Mastertronic game that was very much underrated, I think. Doesn't get the love that it deserves. But basically, the task is you have to colour all of the platform, avoid getting captured, collect the keys, open the safe, and go to the exit. And you start off with 7 lives. And that makes things a lot easier for us. So what we're going to do is going to enter monitor mode. I'm using VICE Plus4 version. And we're going to search for, so we know that we start with 7 lives, so we're going to search for some assembly language, and we're going to use the hunt command. And if you're unfamiliar with it, just type help hunt. And we can enter H, and I'm going to start with 0 through to FFFF. Search all the memory. I know it's only 16K, I know that there's going to be, but the point here is that we're going to look for a, let's try a load A with 7 for 7 lives, and an SDA is usually the most simplest, and the opcodes are A90785. Okay, so we've got some potential candidates. The memory here, 5, 6, we can ignore, and FA we can ignore. So we're interested in the memory locations here, and then let's bring those up here. Let me just resize that. So let's have a look at the code around here. 1F50. Sorry, disassemble 1F50. And 1F64, so we can see here we've got a load accumulator with the value 7 and store at 0F, so 0 page. That's a possible candidate. I'm just going to mark that as yes. Let's have a look at 1F86, which is also here. It's also storing it at the same location is a possibility, but I'm a little bit suspicious now of that one. So I'm going to mark that as yes, it matches, but possibly sus. Let's have a look at 2070. Okay, and 2086, load A, store it at 5A, and jump subroutine. There's also a deck $5A. Compare it with one. This could be a possible candidate, so I think we're going to mark that as yes, as strong. Then let's have a look at 26B2. And again, 26 load A, store it. We're storing it in 2 locations. Could be some optimization, but again, this is another strong candidate. And then let's have a look at 26EA. Another possibility. And then let's have a look at assemble 2BD9. 2BD9, so load it with 7, store it 83, load accumulator with 3C. So again, another possibility for a, oh, we've got something being stored on the screen as well here. Another possibility, so let's go for yes and strong. I think what I'm going to do is I'm going to work backwards through this list. So let's have a look at this one here, 2BD9. So we can assemble 2BD9, or we could poke it with a fill command, but load accumulator, oops, with 7. Oops, I didn't want to do that, did I? We want to know if it's our lives. Let's set it to 9. Disassemble 2BC0, and we can now see that that is in fact 9. So let's go back to the game, and I think if I hit escape, yep, we're going to go back to the start. Starts the game. I can't believe it. First try, look at that. 9, so 9 lives. Okay, let's go back to that address. 2B, or not 2B, 2BC0, load A9, so store at 83. So common is to load accumulator with $83, dec A maybe, or subtract with carry. Right, let's do another. I'll tell you what we can do. We can hunt it, or we can actually set a breakpoint. So given that we're using an emulator here, why don't we just set a breakpoint? If you just type help break, you can see that we can set the breakpoint when it loads, stores, or executes in a memory address, and there's some if conditions. We don't need that, so we're going to add a break. Let's have a look. Where was it? $83. So we want, oops, $83 here. So we want to break on store $83, and this will help us identify the routine now when we lose a life. So let's go back to the game. And here we go. We stop here, 27cc with store 83. So let's disassemble here, disassemble B0. And here we go. Load accumulator with contents of memory at address 83. Subtract the carry. And we've set the carry flag there. Okay. We can do one of two things. We can either zero out or do NOPs for both these instructions, or set the subtract with carry to 0, 1. So what I'm going to do is use the fill command. Sorry, well, we just do help fill. We just provide a memory address and a list of data, and we can use the abbreviation fill for F for fill. So 27CA, 27CB, 2 bytes, and in 6502 the NOP instruction is the EA byte. Now then, let's have a look. Disassemble 27B0, and now you can see here, load accumulator 83, we've got 2 NOPs, no operation. So basically it's going to load the accumulator with the contents, store it back again, and continue. Is that all we need, or is there anywhere else, do you think? So we're now down to 8 lives. Oops, there we go. And if all goes well, let's oops, watch, yep. So we can delete that breakpoint now and exit. Okay, we've still got 8 lives. I'm going to die again. 8 lives. So there we go. Infinite lives. How quick was that for Fingers Malone? And all we have to do is poke 27CA and 27CB in hex with the value of EA in hex, or infinite lives in your emulator. Thanks for watching.